I'm happy to start a new lecture. This is lecture 27. This time I will program online as we have did a lot of times in previous classes. Now we focus on the framework, multicasting framework. Each time, if we want to build an upper level application online, I just focus on one of the particular framework. We already programmed the TNSS, MNSS, the peer-to-peer system framework, and the N-tier framework. And this time, we'll program another application. This application must be more complete than previous ones because this time we will program the system. The scale of the system is larger than before. The scale system theoretically can be infinite, but I think I hope I can finish this system as soon as possible because we have this limited time for each lecture. So I hope I can finish this project in this lecture, but I think it's difficult. If we do not have enough time to finish this application for this lecture, we'll continue to do that in the next time. Okay, this I gave you an introduction about this application for this time. The first one, the one is we call it search engine. Search engine. I think most students or most of engineer, you must familiar with the concept of search engine. Search engine allows you to build application within an enterprise environment. So all the computers belong to the provider of the search engine, of the search service. So I need to construct such a system based on such an environment. Such an environment is stable, homogeneous, and the computing resources are rich. So at least one of the important topics in our class, we focus on enterprise environment. In the next, I think I will give some examples. Talk about some new topics in the later classes. Talk about some non-enterprise environment. It's more interesting for my part of it. It can prove the power of grid-free programming. Okay, search engine is we just focus on enterprise environment. In such a system, because there are a lot of computers need to operate together. This together because we just talk about a multicast. So all the computers need to organize to form hierarchical structure because we need to send data within such a system. These computers are used to to save all the data because a lot of data need to be crawled from the web using crawlers. All the web pages are input into system and saved in those computers. And another way, on the other hand, other users need to retrieve data from all those computers. So that's a two important function we need to provide on such a computer for such a system. So to construct such a system, we have already talked about the root clan, the root child. Those two design patterns and frameworks we need to use, right? And so there are two concepts besides the computers that to be organized as a hierarchical structure. There's still some other computers in such a system. One type of such computer is a crawler. Crawler actually is a typical client. We 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 have uh, we have implemented before. Because we have limited time. The actual crawler, if you want to design crawler, a practical crawler, is not so easy. So we just design a simple crawler. This crawler will send data. This data is crawled by it from the World Wide Web, 3W, and all the web page crawled should be sent to the hierarchical structure so that data can be saved on those computers. To save storage space, the data should not be broadcast to all the computers, just using unicast in our case. That means the data should be saved in a limited computers. The number of those such computers is better for such computers is as small as possible, such a number, right? Because we need to save computing storage. In our case, only one replica. We just make one unique replication for such crowd data. But in practical system, because there are a lot of computers that deploy it around the globe, so the number of replicas are important. Maybe not, that is not unicast. Maybe, but at least usually the data should not be broadcast to all the computers. That is not correct. But in our case, because our system is simple, so we just distribute to unique computers using our multicasting approach, APIs. Another type of client is users. So the users send queries. The users perform reading. The crawler performs the actions of writing. The users perform the actions of reading. The user needs to send a query as a client to the hierarchical structure. And then the query should be broadcast to all the computers because each computer keep different data, right? Each computer in this hierarchical structure keep different data. So all the data should be retrieved to obtain the high quality data. So all the data should be retrieved. So because all the data should be retrieved, the query should be broadcast. Okay, so that's a simple requirement for such a system. Although the system is simple, we just build a contrived application, not a practical application. However, according to the procedure, I believe you can understand it's easy, right? It's easy to construct distributed system, even though such a system is infinite scale. Can be a global scale or large scale distributed system. Right? So you can, if you are interested, you can keep working on the demo I show you and to extend it to a practical system. Okay, so let us start to work on this system. Before we need to work on such a system, we need to get a sample. Get a sample is just identical to the design patterns. We need to follow some design patterns to construct such a system. So the example can be found. Last time we show the demo of multicasting framework. So we just get such a framework and follow framework, follow the structure, follow the design patterns to construct our own applications. So let us start from here. Okay. Okay, let's find the example. Okay, this is the example we need to follow. Okay, we just open them. We show such an example in the previous class lecture, so we can start from here. First, I think we can define a package. In this case, we call it Multicast search. Okay, message. Because we need to define some message, usually we can start from message. But if you are familiar with such system, it doesn't matter. You can start from the code you would like. Maybe you can start from child, clan, and even the root. It doesn't matter. But this time I want to start from this message. First, we need to design a message. For example, we can design the crawl data notification. This is the data. This is the message I want to define. What is this message? This message is actually the data that should be unicast, right? Because this data is, we hope this data, the number of replicas for this data is just 1, and the data should be distributed to the hierarchical structure evenly. So that's the data we need to define. Okay, what is the parent of this data? That's a very important question. This is notification. So let us take a look at one of the notification, unicast notification. And let us take a look at this one. You can see, if we want to design a notification should extend this message, right? Okay, you can see here, this is the client, right? The client sends such notification to the root, but you can see this client is implemented with CS client. It's a typical client. You must remember that if you use this is CS client, right? If you want to send a notification from the client to the server, the notification should extend the message of the server message, not multicast message. Fortunately, the parent of multicast message is a server message, so you just extend. If you extend this message, that's fine. So we just can extend this one, and when the root need to broadcast or multicast this data to its children, such such a message should extend this. If the message is multicast notification, it should extend this message. So to save the effort, if we extend, if the parent for this time we extend the server message, if we extend server message here, it's fine, doesn't matter. This client can send such a message as a notification to the root. It's fine, no problem. It can be implemented. But at server side, such a message should be converted to the message that extend multicast message. Otherwise, this message cannot be unicast, anycast, or broadcast to its children. So for that, to simplify this procedure, one choice is that we can extend the multicast message, even we want to send it from the typical client to a typical server. So that's the reason I want to explain. I want to extend or derive multicast message rather than server message, because on the because this one is lightweight, so it doesn't matter. It does not bring any additional bring much additional overhead to the network programming, to the network. So it's the difference is very limited. So for this case, I just want to extend the multicast message here. Okay, after extended, we need to import it. Import it. Okay, next we just import this new parent class, and then what data should be sent. This time to simplify, we just send the data as string text. Okay, text. Next, we still need to define the constant for such a message, right? This is a constant. This is the same as what we have done before. Okay, so we define config, okay, to define some constants for this message. Okay, this we call it final static crawl data notification. And it's better to use a larger int constant for that. So it's a search constant. Okay, this message, and then we need to initialize the constructor. Initialize the constructor. Initialize the constructor. Okay, the notification is done. What else? What else would we do? For this case, okay, we can design another. If it's possible for us to, because I just designed this code without sufficient preparation. I just think about this application and program online almost immediately. So even though we miss some message, we can improve such a message later, right? Okay, next we need to design the search query request. Okay, this is another message we need to define. Okay, if you have no idea how to design such a message, we just take a look. This is the broadcast request, right? Let us take a look at this one. Okay, just follow this example. This is hello world broadcast notification. We design such a message. We use such a message when we show the demo of the multicast framework. Okay, extend multicast request, and then generate a constructor. Now we need to define the integer, one integer for this message. Okay, next. Okay, then we put a query here. Get query is posted query. Okay, next we need to design the response, right? This is the response. The response parent class is a multicast response. Multicast response, right? Multicast response. Okay, for this time. Okay, I'm sorry. This is response. Then we can get a result. Okay, let us take a look at this one. We also need a constant for such a message. And then this is result. This is the result. Now we need to expose this result through getter. Okay. Okay, what else? For this case, you can see according to the example, there are no string. No string is required for this case because there in the multicasting hierarchical structure, there are no direct TCP connection between the root to most of its children. Just only direct connected children have internet direction. So all the responses different from the client server based system, all the responses are sent to the server using event, synchronous remote eventer internally, right? So we do not need to use the direct internet connection. So another internet connection is established to send such responses. So no output message, out message stream is needed to be designed for multicasting. You should remember that, right? So now, I think we have already finished at least the most important message. Now, let us continue. For this time, I think we can start from here. The root. Root is, I think, the most important component for such a search engine. Yes, okay, we can start from here. Root. And then This is starting point. Search root. Search root. And we can for this time, this one root peer is important. Root peer. This structure is a peer based structure design pattern. Okay, we can call it search peer. Okay, then this one should be defined. This one. Search dispatcher. Okay. Then we need to extend. Okay. You must be familiar with this code. Okay, we can finish this part later. Just work on here. So this is a private peer search dispatcher peer. Okay, create a singleton. This is the code structure. The design pattern requires a singleton for this case. Pay attention to this one. Okay. And then what else? Next, we need to implement the stop. Okay. You are not required to follow the step I programmed exactly, right? It doesn't matter. Okay, stop. If you are familiar with such a system, you can determine such a step by yourself. Okay. Then this one is important. Root master multicast, root multicast. We can, in this case, we just call it, give it a new name, search multicaster. This code is also a singleton. Okay. Next, we need to stop it. add this one. Then what else? Star. Okay, just to make a copy paste for this case. Just to make a copy paste for this case. All right, that's the same for a random point. Okay. Then we need to broadcast or multicast the message from the root to its children. This is for notification, right? Notification easy to be implemented. This time, okay. Let's take a look at this code. Okay, that's fine. This code is good. Almost no change. We do not need to make any change for this code. And then here, I think the code, it's better to send this code in a synchronous manner. Oh no, I'm sorry, it's because it's root. No, I'm sorry, I made a mistake. The message just need to be sent in a synchronous manner for this root, because it's a root is a source of the data. So the data just to be sent to the children in a way, in a manner of synchronous manner. Okay, so because of that, this one is not necessary. You can see here for multicast, I think and the data matter, I think it's blind matter. You can, for the root, you can also send data synchronously. You can also send data asynchronously. There's no difference. It's no. Usually, I think a synchronous way. Okay, let me think about it. Yeah, I think that such a notification asynchronous may be better. Okay, let us try this one. Change it. Okay, just leave here. I don't think we need to change it. Change here. Okay, for we have another notification. Another one is oh, sorry, that's a mistake. This notification, we have notification. This data notification is the date crawl data notification. This data should be sent randomly, using unique. I'm sorry, I make mistake here. Using unique. This is because notification is not broadcast. I'm sorry, I made a mistake here. Right? Unique, because this data should be the number of replicas should be as small as possible. But in our case, because our case simple, just the one replica is needed to be sent to the one of the children in the cluster. Okay, next we need to perform broadcast the read. Broadcast the read need to be performed. We need to get one example. broadcast read. Okay, this is the broadcast read, right? Copy this one. Broadcast read. This is the message. We just need to use search response, right? Search response. We just make a copy. Search response. Search response. Okay. It's done. Easy, right? It's very easy. Now we just have two type of message. One is a notification. Now we need to just use its parent. This is for request. If we use the parent class here, so it's easy for us to just to design such code. When we need to forward, not forward, when we need to send the data in a broadcast manner in such a thread, because then when the data is obtained, oh, let me say here, when the data is obtained, we just need to forward it directly. Okay, here is one problem. You can see here. Oh, I made a mistake. Now this one for search case. Okay, I made a mistake here. I'm sorry. I made a mistake here. This message is different. What different from what I have designed. Okay, at least we also need to design another message, because there is a interaction between. Let us take a look at this message. There is an interaction between the client and the root. The client, in such an interaction, the client is if the user run, there are two types of clients in that case, right? One client is a caller, another client is a user that need to send a search query. So this when the interactions between the client to the server to the root, this action, especially for the search and request, this one we need to design such a message using our traditional approach. So we still need to design the message. Especially important one is if the message request response, stream is still required. But if the request response is performed within the multicasting hierarchical, for that message we have already finished. But there's still message between the client, the user, and the root. So we haven't finished such message. So here we also, for the example, this is the multicast, right? This is a client. You can see there is the name is a client hello world broadcast message. This message extends the server message. This message sent from the client to the root, and the root will respond. The root can send a response to this user. But in this response, multiple responses are put in a list. These responses are collected from the multicaster, all the children in the multicaster hierarchical structure. Because this is the typical interaction between the client and the server. So in this case, the alt message stream is still required. So we miss such a message. So we need to continue work on this message to different. We need to differentiate from this message from the search query we just created. So here we just name it client search query request. Okay. Okay. Client. Client. Then we need to define the constants. This is the request from the typical client to the server. Now the server is implemented with peer, but is the peer contains the typical server. So such a message is different what we have implemented for multicasting. Okay, just the one query. Okay, what about the response? Take a look at this one. This is the info. This project is more complicated than what we have done before, right? Okay, the response. This is also the parent also server message. This is exactly what we have done for the TNCS and the MNCS. All right. Okay. Things usually multiple response should be returned. So we create a list here. Okay, list. And response. Results. Okay. Next, because this interaction between the server and the client, so do not forget the alt message string. This one still required. Okay. This one is a request. Okay. So what about notification? Let us take a look at the notification. Why the notification is fine? Because we no response is needed. So for notification, if you want to send notification, you do not need to. I think we do not need to make changes here. Let us take a look at this one. Okay, this one you can see here. We do not need to for the request response because this request response they're different. For notification, you can for this notification is sent from the client to the root, and the root broadcasts this notification to all of the children, but the message is same. However, for this case, for the request response, they're a little bit different because there is a response is required between the client and the root. So for this request response, this is traditional request response. So this message should be implemented in our traditional approach. In the TNCS, MNCS, we decide such a message request responses, right? However, for such a message, we need to this message. If the root is obtain such a message, the root also need to perform multicasting from the root to its children. In this way, this message, we should not use this message again because this message cannot be multicast. So I have to convert at the root side. We need to convert this message to another type. We'll do that later. So for this case, if the request is need to be designed from the client to the root, it's that the message is different from the root, but from the request message, request response of between the root and its children. But for notification, it's easy because there are no responses between the client and the root, no responses between the root and its children. So for this case, it's simple. Okay, you must understand that. Okay, next step. Okay, we just return here. Return here. So let us take a look at this dispatcher. We must finish the code, right? Let us take a look at this code. Let us take a look at this code. Okay, this is our multicaster. Okay, that's fine. This code is finished. So next, the root peer. So this code we haven't finished yet. Search peer. Okay. Stop. Then copy this one. Okay, that's finished. The method is finished. For this one, start. Start. Okay, and okay. I think here in the previous classes, when we program the server side, we need to pay much attention to the IP address, right? But here, for this case, it's not so important because the peer or the client will interact with the register server. If the register server is known by the client, even the IP address, the port number and the IP address can be obtained from the register server. So for this case, for that, so it's it's not so important if even we mistake for the port number. So this port number can be obtained from the register server. So here we can just make a copy paste. To initialize the peer. Okay, remove this line. Okay. Remove these two comments. Next, we need to start the peer. Then, what else? This line is important. This one need to interact. This line need to interact with the register server to obtain all the IP address of its children. And then we just make a copy. And then not this one is a little bit different because we use search master. Okay, search master. This one is different. Replace this one. We need start search master here, right? You can see here when the search master started, it will use the computing resource from the peer. That's why in the previous classes, when we show the API of the peer, this method is designed. So this search master can share this client pool. The thread pool also share from the peer. So it saves some computing resources. Okay, next. What about this? What's our problem here? No such method. Okay, we haven't implemented. This method is not implemented. The broadcast notification here. This notification, you can see this notification. Oh, this notification is here. This notification AB is a system level implementation. Here, I think maybe this code in the near future I can encapsulate because this code is in the near future. I will show you a more simple way, to implement multicasting in the later cases. Now, I think you still this code look is similar to the sensor level code because you need to broadcast get the IP address of the children. It also need to get broadcast the root IP address to all of the children. It looks like a system, more look like a system level application. Because now we just program a search engine on the application level. So it's looks like a little bit complicated because the system level code is visible to user to developers. So, but in that, don't worry. In the next classes, in the later classes, I will show you more a better way. It saves you a lot of effort in the next class. So here, this notification is we do not implement such a notification, right? However, such a notification looks like a system level message. So we need to this system level message need to broadcast to all of the children. So all of the children can get the IP address of the root. So to do that, we need to add this method to the search multicaster. Okay, add this method. Then you can see the problem is fixed. Okay. Next, okay, this code is almost done. Okay, let us take a look at this one. Star. If this code is finished, we can keep programming for the starting point. Okay, and the peer should be updated. Search root. Search root starting. Okay, this one starting. Remove this line. So now we need to finish this code. Okay, now it's already take us about 1 hour. So I hope I can keep programming this code in next class. And okay, this project is a little bit huge. So we have finished the root. We still need to work on the child, and then the client also need to be constructed. So this project a little bit huge. So we just keep working on this code in next class. Okay, if I have any questions, just let me know. Okay, see you next time. Thank you so much.